in de kerk. Hoe heet dat?
Een preek of een missa.
Mag ik mijn zonnebril halen? Nee, ik wil niet hoe je zo'n ding bouwt. Ik wil er een.
Hij is heel gewend aan, zeg maar, being hackled. Ja.
Please heckle. Preken voor volwassenen en kinderen.
Ik ga dat echt doen. Hey Flap, goedemorgen.
Gewoon aanstaren, hè? Helemaal niet lachen. Alles wat hij zegt, nee, zitten Ben je al klant?
Dat is 2 keer klant.
Ik zit op server 1.
Sorry.
Maar waar zit ik dan op? Ik sta ook op server 1 of niet?
Nee, je zit op een van mijn bakken.
Ook zit op de testserver.
Nee. Je draait op de productiemachines.
Ook serieus?
Ja.
Wat is dat voor een raar?
Ik verhuis je wel.
Ja. Ik weet wat vaak gedaan.
En dan merk ik het zelf niet.
Nee, ik ook niet.
Dat is altijd. Hij betaalt niet eens. Sponsor, precies, sponsorcontractje.
Moet er even bij zeggen, we zijn al live, hè? Dus
Heel goed. Preek voor volwassenen.
Ik zou voor kinderen doen. Ik denk dat het niveau hier niet hoog is.
Overdenking tijdens een begrafenisdienst? Nee.
Staat alles goed in beeld, jongens? Ook de BSD?
Nee,
Wat?
alles rechts van Michel valt weg. Andere kant, mijn rechts, jouw links.
Dat zei je niet.
Ja,
Dan wissel ik ze om hoor.
ja, dat lijkt me een heel goed idee.
Staat de banner wel in beeld?
Staat de banner in beeld?
Ja, die staat in beeld.
Oké.
Alleen de O is weg.
Het enige wel belangrijk vinden.
Dan zitten we voor jouw beeld. Ik denk dat wij naar de andere kant gaan.
Wat? Ik hoorde het niet.
Hou zo.
Ah. Ja, nee, daarom. Dat is niet eerlijk.
Hij Michel hoef ik niet te zien. Ik zie zijn slides wel. Hey, jij laat het van je hekkelder.
Ja, maar wel leuk. Maya van SIDN.
Ja, Michel kan nog een tandje beter als hij niet zijn winterdekje op heeft.
Nee. Moet kaler.
Daar hebben ze toen deze sfeer uitgevonden.
Heb ik.
Ja, ik ook.
Hij gaat
Niet scheermes?
naar Sales
Af en toe,
Alexander.
in de zonde en in de zomer.
Dat is het bijna.
Nou, niet gezien.
Graad buiten, jongen.
Sfeer, precies.
Daar denkt Dennis anders over.
Oh, ik doe het.
Welcome to my TED Talk. Ik zeg, komen mensen binnen? Welcome to my TED Talk.
Hey, woe!
Hey,
Hey,
hey.
Hey, psychic, psychic.
Dat kan ik, ja.
Eet smakelijk.
Hey, schatje.
Pas op, veel interactie doen.
Vannacht...
Ja,
Ik hoop dat er
oordeel
wel meer
in,
komen.
dus je hebt vandaag helemaal niks
Hoeft
gemerkt.
niet. Hoeft niet.
Jawel,
Nee, hoor.
wel leuk.
Voor wie?
Dat was geen interactie.
Voor jou?
Nee, kijk, er wordt nu al gehackeld en ik ben er niet eens begonnen. Nee, dat moet.
Heb je nou je preek al af?
Maar wat?
Je preek?
Ja.
Oké.
Nee? Bijna. Ja. Waarom? Stink ik aan mijn mond?
Ik krijg wel een Vinci hoor.
Smint.
Ja, hoor, ja.
Was daar, hè?
Ja,
Helemaal achterin.
ik weet het. Ik loop zo direct daar wel naartoe. Hallo.
Ja, ik kom hier knuffelen. Hallo. Hallo.
Morgen, morgen.
Dutch or English? English.
English, possible?
English? No, no, no. The tradition is 15 minutes in the talk, we switch to English.
In the question round.
Het juiste woord dat je zoekt is sermon.
Hmm.
Sermon, ja.
Welcome to the Seaman. But. Oxygen.
Doet iemand het eraan dicht?
Ja.
Ja, maar
Daar kan ook nog van gaan.
Welkom. Blijf gewoon hier staan de hele tijd. Ik had hem ervoor gezet, maar dat mocht niet. Nee. Ja. Ja. Goedemorgen.
hey Carl, if it starts in Dutch, raise your hand after 1 minute and say please, not 15.
Hij stond er al bij.
It is.
Social engineer Misha.
I haven't started yet. I'm waiting for more bodies. Te laat. Ja, ja, ja. Jullie kunnen nog naar de wc, tanden poetsen, douchen, deo.
Alleen deo.
Axe.
Nou, dat is een record
Hey.
voor een niet aangekondigd praatje.
Oh, dat is waar.
Gisteravond was maar Misha. Oké, daar wordt vast iets ook mee.
Welcome to the talk, Misha, by Misha. This talk is going to be recorded, unlike the other Misha's talk.
So everybody chose to livestream.
Ooh. Wat? Oh. Maar hoe is dit porno, zijn?
Het doet het niet voor iedereen.
Nee? Lampjes aan een string? Balletjes? Nee?
Waar is Brenno? Is met Brenno leuker. Iets liefs. Zullen we knuffelen? Oh nee. Zullen we knuffelen? Oké.
Nou, die gaat ook repeat op dit nieuwe straks.
Anders krijg ik op mijn flikker van Psychic. Niet dat dat erg is. Wat zeg je?
Oh, Psychic tellen we ook mee, toch?
Waarmee?
Met hoeveel mensen meekijken.
Ja, hij moet wel. Nee. Ah! Make it stop.
Hoeveel keer is het dat je dit praatje doet?
Ja, dat is een andere.
In mijn hoofd? Oh. Tweede. Nee. Jij? Jullie? Fuck. Ja. Ja, dit is niet om klanten te werven, dit praatje. Nee, nee. Precies. Zonder klanten. Het liefst. Moet ik weggaan? Graag. Gewoon buiten gaan staan. Hey Dimitri. Morgen. Kunnen we beginnen dan nu? Je bent er.
Goedemorgen allemaal.
Goedemorgen.
Lekker geslapen?
Nee.
Mooi. Nederlands? Engels?
No, 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 no.
Yes.
No, no,
Yes.
no.
We
Tradition.
are very inclusive.
No, no. Tradition is 15 minutes in the talk, we switch to English.
No.
Yes.
Okay.
All right.
Good morning, y'all.
Y'all.
I slept twice as long as
2
yesterday.
hours.
Actually, I slept the last 2 days. I slept 6 hours, and yesterday I slept 6 hours. So that was an
Nice.
improvement. I want to take the opportunity to, before Misha starts, to point out that Secura is here. Some people have already found them. And Secura have an industrial control system set up, which you are all invited to hack. So I look at the people there, I know. So please visit them. They are in front of the, when you go to the hack area, you go up to the elevators. In the left, there's a room with a test setup, and you're all invited to see if you can hack, you can sniff. And they have comics. Free comics. So yeah, so for the people that are interested, please visit them. We value both
Not now.
both OpenBSD.
After the talk.
So after the talk,
Thank you.
you're all invited to go there. So now, without further ado, I would like to introduce to you Misha Peters, and he will talk about the OpenBSD hypervisor. Please come in and enjoy his talk.
Welcome to the Church of OpenBSD. This is going to be a Siemens sermon. No. I'm going to talk about the OpenBSD hypervisor. A little bit about myself. I started working at Access for All a long time ago. Walter was there a little bit earlier, I think. And since '98, I've been working for vendors, networking, security vendors, all these kind of things. And also around that time, I started with FreeBSD. I think I was one of the ones that introduced FreeBSD to Access for All. And also after that, I started co-location, primarily for my own hardware. I rented a rack with 3 friends, I thought, and then one of my friends said, no, I'm not going to do it. And I was the main contractor, and I thought, okay, shit. Now I have to get other hardware in there. And that exploded a little bit into 8 racks or 10 racks at one point. Still hosted at Access for All, so I'm looking for a new home when it's becoming KPN. But anyway, what about you? Who is using OpenBSD? Ooh. Any other BSDs? FreeBSD? Dare I say NetBSD? Oh. All right. Who is using the OpenBSD hypervisor? All right. Nice. Who has a VM at OpenBSD Amsterdam? Oh, I don't know. I know you. All right, cool. So it is like a team customer meeting. All right. So I'm going to talk to you about how it all began, and I'm going through the setup. You can also read about the setup on my website. I've got everything documented. Some things that other people have already started using, so that's quite cool. But how it all began was I started using jails on FreeBSD, Kubernetes, and Docker. That's now to segment things out. And I've always been looking for virtualization or easy virtualization. Then came along Beehive on FreeBSD, which is not simple. It works. But then some guys on the OpenBSD communities thought, okay, we're not going to import Beehive. We're going to build our own from scratch. And that became VMM VMD. And as a start, I looked at that, and it was getting there. I think after 2 years, it became a little bit stable. So I thought, okay, let's do this, because I have some spare rack space, some hardware, more importantly, some spare IP space, IPv4. And I also always wanted to have like a domain with something BSD in there. So I saw that openbsd.amsterdam was free. I registered, no idea what to do with it. But I also wanted to have a way to give back to the community and to actually take this hypervisor and see how far we could take this. So that was pretty much the start of it. So where is it? As you might assume, it's in Amsterdam. It's in a KPN data center, DC2, at the Barbara Strozzi-laan, if people know it. It was called something different, which I forgot now. And primarily the hardware that I'm using is Dell R610s, Foundry switches, if people still know Foundry. Cool. And also, and that's connected to a Foundry MLX, and I'm doing BGP to access for all, so I can decide where the traffic goes, and if part of access for all collapses, then I'll go through the other gateway. So the whole thing actually started on Twitter, where I just started playing around. I said to some people, hey, I have a machine that I'm playing with, who wants a VM? So I'm one of the first, dare I say, victims, I guess? Happy customer, okay, cool. On server 1, so VM number 6 was there, and I thought, oh, this is pretty cool. So I did a little poll on Twitter, what people were willing to pay for a VM with these specs. So 512 of meg, 50 gig of RAM, V4 and V6. Because there's a lot of companies out there that do this en masse, and they charge like €2 or €6 or €10 or whatever. So I thought the sweet spot was around €5 a month. So I thought, okay, I have some other spare hardware. Let's get going. So this was the first proper machine online, and the reason why I say proper, the first machine was like 8 gig, CPU, a lot. So as soon as I started adding more VMs, it would reboot, because it couldn't really deal with the memory. So this machine had a little bit more memory, more disk space, and this is still running 45 VMs, if I'm correct. And of course, the whole idea was that as soon as you have a VM, part of the money that I charge, I donate to the OpenBSD community. So the first donation that I've done was in, can't read it, in July, I think, yeah, end of July, to the OpenBSD Foundation. This was for €400, and so that pretty much means 40 VMs. So I donate €10 for every VM, and €15 for every renewal. And this actually took a while to deploy. So everything was done by hand. Also, one of the machines crashed, so I had to redo everything by hand, which was not fun. There were no tools around it to make it easier. I developed them gradually over time, which you'll see. But yeah. So now, some statistics. The last month, I donated €395. In total, 5,000 plus. And in 2018, I donated €1,850 in 6 months, actually. 2019, 3,500. And there's 10 active hosts at the moment, so 10 servers. And what I've done is basically for the money that I made of all the VMs on a certain server, I bought a new server and started over again. And I actually have to start investing in server number 11. And there's currently 334 VMs active, which is mind-boggling still. I don't know why people do that. Even who's running production on OpenBSD Amsterdam? Good. Thank you. But there are actually people running production. which is a little bit scary. Yeah. So, what do you get? You get a opinionated VM. Now, this has changed a little bit over time. Initially, it was more like, this is the install that you get, these are the packages that you get. But now there's some changes in the way that OpenBSD upgrades, and it doesn't make sense anymore to not install certain things. So it's going to be more vanilla OpenBSD, but anyway, still my opinion. And you get, by default, 512 meg of RAM. You can get more if you want, 1 gig. You get 50 gig of disk space. You can also get more. You get 1 IPv4. You can get more. Not a lot of people have done that. And you also get a IPv6 range. And the idea is that the host, not for all, is the gateway for all the VMs. So how is this set up? Everything that we, 99% today, that we use is in base. So OpenBSD has a very complete base operating system. You can run a router, you can do BGP, web servers, load balancers without installing anything. So it's quite cool actually that most of the things that we can do and use to deploy is within base. Perl is in base. Some of the tooling that the OpenBSD guys wrote are actually done in Perl. So I thought, I know Perl. So I started actually doing some deploy scripts in Perl. And of course, the VMD daemon, DHCP, auto install, for people that know it, it's a way to actually automatically go through the installation process. There's a package called site.tgz, which you can have your own packages or configuration that you can automatically take. I'm using the HTTPD from OpenBSD, and then of course VI, everything's done in VI. So what the Perl script does is it will create all the configuration files that are needed. It will create a user. It will put the user in the doas config. So for people that don't know OpenBSD, doas is the version of sudo on OpenBSD. Because like everything else, the guys from OpenBSD go, okay, this sucks. It's way too complicated, way too many attack services. We will write our own, which is also what doas is. And it also creates the image. So the vm.conf looks a little bit like this. So I have a block of configuration. No, mine doesn't show up. Where I specify the VM name, who the owner is, where the disk is located, how much memory, how much disk space, and I assign a static MAC address to a VM, which I then use in the DHCP config to actually tie the IP address together. So you can type in your IP address manually. If I have to move your VM, it's a little bit annoying for me, because then I cannot really reassign your IP address back if something is changing or whatever, or gateway. And also the file name auto install basically tells OpenBSD to look for PXE boot and then an installer file to kick in the automatic process. One thing you can also do is say auto upgrade. So if you want to upgrade from there on to other releases, you can also do that in automatic fashion. So what the auto install looks like, it's primarily IP address, username, password, so that I can provision the VM. I also put the SSH key in there, so that you don't need to have a password in order to connect. And also the install file. So as you can see here below, set name. I remove all the X things, and then I add the site for the local configuration. Now, if people are familiar with OpenBSD, there's now a command called sysupgrade, which basically upgrades the whole system with one command, and it assumes that everything will be installed. So removing certain sets these days doesn't really make a lot of sense anymore. Then the site config, what I do there is to basically, as soon as you want to install any packages, that's the install URL, so cdn.openbsd.org. So as soon as you say package add something, whatever, it will get the packages from there. I also tell the VM to not use sound, because there's no need. And also to set the clock as soon as it boots. Now, for the people that are familiar with OpenBSD, that flag will go away. It's deprecated. So they're doing some clever stuff on the back end, so that might no longer be needed. As soon as the upgrade runs, you have the ability to also run sysmerge, and it merges configuration files. And what I've noticed is that if people don't pay attention, the TTY's file gets overwritten, and the default settings for the console are 115 to connect. The default in TTY's is 96. So what happens is that people go, okay, I cannot really reach my console, or it hangs and it consumes a lot of resources. So this was one of the reasons why I put that in, so that as soon as you run the system upgrade, it will not overwrite that specific file. And one of the things that I've added in the last couple of days is that for the people that know him, Job Snijders. No, he's from the He's from NTT and Nog. He also has a VM, and since we started, so OpenBSD does a major release every 6 months, and during those 6 months you have like errata, and you get updates on certain packages, and some of them are quite needed, like security patches. And he complained saying, hey, if you roll this out, just give me all the sys patches so that it's not vulnerable. And I went, oh, okay, that's a good idea. So what this does, it will actually tell the installer will tell the system, as soon as it boots for the first time, run all the sys patches. It's not a default thing, so this had to do, install.site basically tells it to add it as soon as the installer is done, and then as soon as the machine boots for the first time, it runs rc.firsttime, and then in rc local it will run that code, and if it's done installing, it will actually reboot, because otherwise some of the security patches are not applied. So that's now there. So as soon as you get a VM now, you get not only like the install or release, but you get actually all the patches applied to it. I'm using HTTPD, as I mentioned, to serve all the installer files. Very simple configuration, just for kicks and giggles. I'm using sensors D to basically tell me when a disk is broken, which is quite useful. It doesn't do that by default. So this basically checks if the RAID is still intact. If it's not, it will send me an email. Quite useful. Also, when a machine reboots, it tells me, hey, disks are okay. So how does it actually then work to deploy a VM? What I've done is every single machine has a block of configuration that tells it what the IP space is, what the IPv6 is, the start IP address, the VM config, what the default VM config is. So if I need to change it at a later stage and say, okay, everybody gets 1 gig, for example, I can very easily do that. So this is a file that I have per host. And what then actually the flow is, you can register for a VM on the website, you can put in all your details, I'll show the form. I run the Perl script that does everything, then I restart DHCPD, I reload the VM config, and I start the VM. And since 2 months, I still had to hit A to start the auto installer. That got a little bit old, so I fixed that. So the form looks a little bit like this. You can put your details in. I get like a nice text file that I put in a text file on the host. The deploy script is run. It will create the auto install. It will create the user. It will create the actual image that is being used to install. Then I said I reload VM. I restart DHCPD, and then I start the VM directly in console mode, and I hit A. As I said, that got a little bit annoying, because then you also have to wait until it's done, shut it down. So I thought, okay, this can be done better. How can I do this? TCL. So I have a wrapper script that actually does all these steps, and it kicks in 2 TCL scripts that look a little bit like this. If people are not familiar with TCL, it's a great language. So it actually connects to the console, it will wait for a certain prompt, and it will hit A for me. Win. Once that is done, it will actually exit the script, and then since this is run in the shell script, it will kick in the next expect script, and that will actually wait for the fresh reboot of the VM, and it prompts a login prompt, and then it will say success. So I get a nice beep in Tmux as well, so I know, okay, VM is done. So I don't have to wait for it. So one of the things that I still have in mind is that the VM will actually send you an email when it's done. So that's the goal. So the VM will actually tell you, hey, I'm done, you can now log in. But it's a little bit trickier. Anyway. So during this whole process, of course, we found a couple of things that were quirky, or as I also put on the website, it's in active development. Things break, and things do break. But other things were also, when I started, one of the things was, I asked on Twitter as well, so what do you need if you have a VM somewhere? And someone said, console access. And I went, okay, yeah, that doesn't really work at the moment, because the person that can actually connect to console is root. Or you have to be in the wheel group, which with a bunch of people that I don't know on a host, adding them to the wheel group, that's probably not a good idea. So one of the first things that I did was talk to Rijk. He's one of the OpenBeast developers, did HTTPD, RelayD, crazy German. So I said, hey, how can we do this? People need to connect to the console. So okay, yeah, that's actually interesting. So now you can set the socket owner. So you can say, okay, who owns the socket of VMM or VMD? You can specify that to be a group, so whoever is in that group can actually connect to that socket. And then in the VM config, you then specify the actual user that can connect to that VM. So not everybody can connect to everybody's VM. You can only connect to your own VM, but you have to be in a specific group. So that was quite cool. One of the other things is for a VM to boot, it needs to have a tap interface into the bridge. By default, there's only 4 tap interfaces on OpenBSD. And it gives you a very peculiar error message when there's not enough tap interface. Just says, well, I cannot start. Oh, okay, why? So that took some while, actually, to figure out what was going on. So what I, by default, do is just create 50 tap interfaces, so that's no longer a problem. For people that don't know, JOT is similar to sec in Linux. Linux people here? All right. Okay. Fine. It's okay. It's okay. But goed. All the Dutchies here. The other thing that you can do with JOT is it can also cycle through characters. So one of the things that I do to create like a random password is actually to use JOT, assign ASCII. So 33 is exclamation mark, and 126 is tilde. So everything between that I use to generate a password that is 20 characters long. And what I do is I shove that generated password into authorized keys at the end as a comment, so that you can log in with your SSH key and then take your password and the root password out of the authorized keys. And Rijk actually thought that was a good idea, so he started using that for his deployment on Azure or AWS or something, I don't know. Some cloud giant, I guess. So I thought that was quite cool. Sometimes I do think of clever things, not always, but. So one of the things that was a little bit annoying is if you have 40 VMs running on a machine, to start them all the time and to stop them all the time. So enter a for loop with awk and a sleep that basically says, okay, after 30 seconds, then the next one, and then the next one. Because if you do it too quick, it might screw up your disk, and they have to hang in fscheck. So that's no fun. So they figured that out, and they went, okay, yeah, that's not a good idea. So they had a flag called -a. So now you can just do stop -a, and then W means wait. So it waits for a VM to shut down, and then it will do the next one. So that was quite annoying. Starting VMs is still annoying. They're fixing that. So the idea in 6.7 is that you can run start all whatever, and it will do 4 at a time, and then wait, and then 4 at a time, which I don't think is still a great idea, especially when the machine crashed and you have to wait for FS check. So I have one in the good condition, sleep 30, and one in bad condition. When the machine crashed, I do 90. So then at least I give enough time for the FS check to finish, so it's not impacting, or it doesn't. If I don't do this, booting of some VMs will take hours, which is not fun. Another thing which was trial and error. In the beginning, there were some connectivity issues. I started investigating. They're not done yet. But one of the things was the ARP queue of OpenBSD by default is set to 50. So if you have 40 VMs or 50 VMs and you're in a broadcast of a /24, you get errors and drops and things like that. So I increased it to 1024, and that for some time fixed the connectivity problems. So what user experience? One of the very interesting things which I have to admit Linux has solved is clock drift in a virtual machine. It can be quite severe if the machine has boot up and it couldn't get enough megahertz from the CPU. Then you could have like 5 minutes off within quick. If you run Alpine, for example, I have one Alpine VM. The guy has to sync the clock every second. Yes. So yeah. They are aware, but everybody goes, and I have a nice page on the website, clock.html. One of the main developers has like this long essay about why it all sucks and that it's a very hard problem to fix. And yes, Linux has fixed the problem. But it's one of the things that everybody goes, yeah, we have to do it, but no one wants to do it. Another thing, especially in the beginning, I got a lot of questions about this. For some reason, there's a high interrupt rate, and it's just to do with how the interrupts are handled in VM. Nothing to see here, move along, but it's still, people still find it, I find it annoying. Then there's still some severe connectivity issues. The interesting part is that it doesn't really matter if there's a lot of VMs running on a host or not a lot. I'm seeing it on machines that have like 6 and 40 and everything in between. And the only stable way that I figured out to fix this is to run this command at reboot in your cron that does every 5 seconds, well, clock drift every 10 seconds, a ping to the gateway. I thought this was in Bridge. During EuroBSDCon, if people know it, it's an event every year that is held with just a lot of BSD nerds. And we really thought it was the bridge that was causing the problem. So initially, I had a layer 2 setup. Is Attila still here? Good. Attila likes layer 3. It's a layer 2 setup where I have a public interface in the private bridge, and then all the VMs are also in that bridge. So someone said, okay, let's do a routed setup. So I have a private bridge, and I route all the traffic out through the public interface. But right away, I saw that there were a lot of problems as well. So someone said, okay, yeah, do some packet traces. And I hadn't seen Sake's presentation about Wireshark yet. So I had a lot of different files that I had to go through because I had to do a lot of different tabs and vethers and whatever. Because the idea was that certain broadcast or ARP packets were not answered correctly or were leaving the wrong interface. Now, I think we have proven that that is not the case. And now I've really stumped the OpenBSD developers because they have no clue where it's now at. So this is where we are. Another thing, what I've seen, what you might have seen, is unresponsive VMs. For some reason, the VM can just take 100% of CPU, and it would just go hanging there. That is hopefully now fixed in 6.7. So one way, or the only way to actually make that go away is to do a kill -9. VM control stop -F force that you can do as a user doesn't cut it. So people said, yeah, can we do that now as well? So what I've done is actually, that is where the do as configuration comes in. So every user has a permit, no pass, basically means you can run this command without a password and you can kill your VM. I had to test that first a couple of times so that you could not kill other VMs. But that's then the command that you can run. So do as pkill -9 -f and then your VM ID, and that works quite well. And if I see it, I'll do that for my users. So if you say, hey, my VM rebooted, that's probably the reason. One other thing, the last part actually, is I've also had people that wanted to do redundancy. So they want to have a VM on server 2 and a VM on server 8, and then have redundancy between them. Now there's two ways that you can do redundancy, is with layer 2. And OpenBSD has a nice VRP, a free VRP version called carp. And that you can actually do in the VM if they're in the same broadcast domain. So if they're in the same layer 2 subnet /24, on VM1 you can run that command, which basically tells you, here's my IP address, this is the virtual ID. You can give it a password, Cisco for example, and what your carp device is, so the actual public interface. And then you have to tell it, because for some reason Bridge doesn't send these packets to each other. You have to do this on IP. So you have to tell it, this is my peer. And on the other side, you have to point it to the other direction. So I do this on some hosts. So my RelayD setup runs like this. My DNS setup runs like this. But if you want, you can also do this with layer 3. Which is what I wanted to do, because people said, yeah, you have to go route it. I went, shit, but then how do I do my failover? So enter RelayD. And the nice thing with RelayD is that you can do health check on from this you have to do from the host. So if you would want to do this, I have to do that for you. You can do a health check on a host, and based on that health check, RelayD can talk to BGP. And it can say, hey, inject this IP address in your BGP table. Which is what you see on the left side. So the left side is the RelayD config. So I have the VM that I health check, and then the route is basically the IP address that I push into BGP. And then the health check script is below that, because it has to give, you have to give a certain error code back. And then on the right side is the BGP config of the host, which then talks to my router that says, here's an IP address that has to go to myself, because I have a host here. And then on the other host, you can do something similar, and you give it some metrics and things like that. So that's the layer 3 config that I played with. And based on this is actually how I started investigating the connectivity issues, because my RelayD would say, hey, for the last 10 minutes, I cannot reach this VM that's on the same host in the same freaking bridge. But anyway. So that was the setup. So I do have a wish list that people agree, for example, that PXE would be a good thing, so that I can completely automate the whole process without TCL. Everybody would prefer no clock drift. And then I still have to tackle the connectivity drops, which is just a hard problem. Anyway. So some people that have been working on this, I've done this at EuroBSDCon, and all these people were in the room, so that makes a little bit more impact, sorry. But the nice thing is, based on all the stuff that I've been doing, I got an email yesterday from one of the kernel guys that says, hey, there's like a little problem in VM. Here's a patch that's coming. So apparently, there's now a vulnerability where from the VM, you can DDoS the host. So please don't do this. After I patched, you can try. But I've now got the patch that I can apply already before it comes into like a proper sys patch. And the last time we counted, there were 47 people working on VMM VMD. And the interesting part was we started also counting the commits. And Ori, who did the QCOW2 image, I think he did 5 commits. And Mike Larkin, who's the main VMM developer, he went, how did he do that? That's impossible. But apparently it works. Anyway, just some side note. So thank you for coming to my TED Talk. I have some links here. I also have them without the logo, so it's easier to read. I can publish the slides so you can actually click on them. But anyway, any questions? All clear? Tired?
I have a question.
Yes?
Oh, wait. Oh, yeah.
Zet hem dan eerst aan.
Yeah? Oh, I think it works.
Yes.
No, my question was, well, for me the news for OpenBSD Amsterdam was that there was actual hypervisor for OpenBSD. That was the reason why I got my VM.
Perfect.
Do you know of other people doing projects similar to this one, or are you the only testing ground for this?
I think I'm the only major testing ground. A lot of the OpenBSD developers are using this for a very specific use case. So if people are Mastodon, there's bsd.network, which is an instance on the hypervisor, but I think it's the only instance. So they're not seeing, every time I go, so anybody else seeing this problem? No. People have approached me to do this, but where they go wrong is either IP space or traffic or power or combination thereof. The nice thing is I have a colocation company for a long time. I have rack space, I've got power, traffic at access role currently is not a problem. So for me it was very easy to do this. If you do this in like a standard colocation facility, it's a little bit trickier because the cost, also the amount of money that I ask for a VM is quite low. And the reason why I do this is not to make money. I just want the thing to run on its own and that I can donate. So I think to do this at a scale, it's quite tricky to do. But during the EuroBSDCon, Rijk Fluter, he actually grabbed the mic and said, "This is great, please start doing this, because that's the only way that this thing becomes better." So if you have some spare hardware, start deploying and playing with it. Was it all clear, or no one cares, or just... Yeah? All right. That's fair. Were people expecting the other Misha? Could also be the case. Okay, thank you.
Slow clap. Lunch, wat ik heb het gegeten.
Ja, dat ja. Die timing is niet handig.
Ja, nou ja, dat is
Ja, we moeten even een uur wachten.
Cool. Oh, wow. Ik heb een keep-out zone. Nice. Maar rustig aan. Mag hij nog even uit? Mag hij nog even uit?
Oh, was
Doe mij nog wel een wintermaat mee. Nee. Als je een wintermaat moet nemen, dan
is daar niks uit. Ik moest wel eens achter de mooie kastje. Maar niet. Kou niet helemaal super wel.
Oh, wow.
Good afternoon and welcome at the badge team talk. Thank you all for being here. A lot of people played with this badge, and this awesome badge team will tell you all about it. I hope there will be lots of questions and interaction, but please give it up for the whole badge team, but in this case also for Sebastius.
Cool. Kijk maar even. Moet even doorgeven. Heb jij die alvast? Oh. It's my keep out zone. I can't go there and I can't go there. I can only run away. So, hi, welcome to our little presentation called The Adventures of Badge.team, Sunk Cost Fallacy as a Lifestyle. We owe the subtitle to my friend Jurt, who wrote a little piece about the Decennium badge, where he claimed, for badge life people, sunk cost fallacy is not just an option, it's a way of life. Yes, that's very true. So, I'm going to take you through how this little project came into existence. We're going to show you what it did to the event and maybe some plans afterwards. I have two people joining me later on. That's Saka, who did all the puzzles, the main quest design, which you all had fun with, and Benatsky Ralph, who did the software. And I'm leaving out a bunch of people, but that's going to be fine. So, it's going to be fine. No, it's a team effort, and I'll thank everyone in a minute. That's going to be fine. So, we had some design goals, as usual. We always set a set of rules to make this work. We want a name tag. That has to be, a badge has to be a name tag first. You have to be able to write your name or show it on a display, whatever. People need to know who they're talking to, else it wouldn't be a badge. We need to make people connect or interact. I think we succeeded. It should be incredibly easy to get started. No installing tool chains on your laptop, no looking through thick manuals, plug in batteries, go. It should be reusable after the event, and it should be available at the entrance. So this was November. This is our timeline. Okay, yeah, we're just going to do something basic because we don't have any time. A basic soldering kit, maybe a heart shape with a Hackerhotel logo on it, and done. Okay. And then Dimitri came. Here's some budget, and I want this, and I want, and it was starting to control freak us. We love you, Dimitri. But then at November 12th, Renzo started the secret Hackerhotel 2020 design group, which he wasn't invited to. And we went and we said, hey, we're going to make a badge for you. It's going to be cool. And you can't know anything. That's it takes a huge amount of trust to trust us with the money of your sponsor. So thank you for that. So, credit where credit is due. This is all Nicolette's fault. So she said, so I'm obsessed with the fact that the heart shape we use today was first depicted by Egyptians, because crocodile hearts look like that. Okay, we could go full Egyptian theme. Could we really? Should we add puzzles to the badge? Oh, crap. So, the 12th of November was, I think, the most productive day in terms of concept. A lot of stuff was thought up back then. Simon says the theme. Nicolette also did some cool sketches, like our heroes escaping from the evil cat, Egyptian cat goddess Bastet, which I'll talk to you in a bit. Took some convincing for our teammates. I still don't get a strong feeling by the Egyptian stuff, though. Doesn't feel like Valentine. That's the point. In the beginning, it was related. Well, Bastet is the god of love and of cats and of sex and of warfare. It's a very active goddess. So it's totally related to Valentine. So we can pull this off. And Nicolette started scribbling away with our ideas, and we were first on a thinking like, let's do something like a tablet, and then add some art on top, and then some components in the middle, which also looked very pretty, but it didn't feel like it yet. In the meantime, Ralph started to design a little dev board. So the little processor on your badge, let's see where it is. You can just see it just below the batteries. That little processor, that's this big, huge square you see in the center. flipped upside down, and then he added some little wires in to start prototyping. And before that, we went into looking into Chinese microcontrollers, which are really cheap until you need to get the dev kit to program it. That costs 200 euros, and you can only get them in a few months' time, and you can only use it on Windows. Okay, no. We'll just use something that has an open source toolchain. So we came up with designing a challenge badge, and we came up with designing a mixed reality escape room. 6 challenges. That's why there's the letters hacker on the front on the necklace. So 2 challenges are up front on the badge. There's one you do with each other. That's what some people have called the badge STD or the badge sex. Thank you for that visual cue. Yeah, great. And there were a few hidden inside the badge, so you can get started really easy. Just push a button and stuff will blink, and then you push another button and it will glow angrily with red eyes at you. And then you did it wrong, and you try again, and suddenly you figure out, hey, this is Simon, I can actually do this. And then you figure out, hey, if I switch it off and on, it doesn't reset the random function, so I can just do the same pattern over and over again, and win really easily. So, what did you learn? If you haven't learned it already, you learned some basic decoding. Some people decoded the lanyard, other codes. Some people fixed barcodes. Who would have thought you would have fixed barcodes? It's cool. Connecting USB serial and solving impossible puzzles. So, let's look at some early concepts. So, I don't know if this was a few weeks later, but relatively fast after our original concept, Nicolette came up with this concept art. This was still a sketch. This is not the finished art. This is a sketch. I have no idea how she does it. To the left was the early prototype by Ralph. That's all the parts that are on your badge are there. And to the right is a prototype. There's 3 of them. We're donating one to Jenny's, well, not Jenny's, but to the badge museum she is putting together. She is very adamant about that. It's not her museum. It's for us all. So go visit it at EMF to see the entire collection. Hackerhotel, the first tryout. I need to take a sip, just a second. So, the prototype boards to test the circuit came in the day we had to order the final production run. So Renze, to his credit, built 3 of them, verified the circuit working, and we went, and away we went. And then 2 days later, oh, there are some short circuits in the circuit because KiCad is stupid. So this whole front, all the bits that are in gold, are conductive. Somehow KiCad isn't aware, at least in the way we worked with it, isn't aware that it's conductive. So we just added some pins and pads and the stuff to the front, and then it all shorted out. Yeah, well, it's what happens. Let's see here. This is where we were. So what's on there? There is some hardware on there. There's an ATtiny 8-bit microcontroller, 10 megahertz, 16 kilobytes of storage, 2 kilobytes of RAM, 265 bytes of EEPROM. We added in a 24C265 32 kilobyte EEPROM. We added a Hall sensor. That's why you had to move around a painting with your badge at the reception area. There's a light sensor, which forced you to put your badge somewhere in your bag to make a challenge work. There's a third sensor that's inside the ATtiny, a temperature sensor. So that's why people were running to the hot air gun and roasting their badge and then running outside to cool it down again. It was like, we need another sensor. Hey, there's a temperature sensor inside. Ooh, what can we do with that? Yeah, that's how it came into existence. There's 30 LEDs of them, which we came to regret a bit later. I'll explain that to you in a bit. 4 buttons, an audio jack, which does both audio and enables badge sex. So it's a multifunction connector. And this time, that one part was not reversed. Yes.
What about the green?
Hmm?
Proper green?
Oh, the proper green. I'll let Ralph tell you about that during his segment, because he has very strong opinions about LEDs and their colors. So I'll let him. I'll let him finish it up. Yeah, I have some opinions too. I detest the color blue in LEDs, which has been overused for quite some time. So I'm happy to have been in 2 projects which have not a single blue LED. So, in China, the PCBs were made, and then a few days before Chinese New Year, I got an email saying, "Hey, I'm very sorry, but I can't. I haven't received the PCBs yet, so I can't put them into the assembly line, and the assembly company won't take any new orders." So yes, we have some bare PCBs in China, 350 of them, and no one to assemble them. So we were already planning to, okay, well, in theory, we could hand pick and place it and put it through a machine. And then Michael Stegen, where are you? There are you, said, "Hey, I've got a pick and place machine." Okay, we did some math. Okay, that should take 20 hours to do. We can in theory assemble it ourselves. So we arranged all that. And then the next morning, and I also called Dimitri and said, "Hey, this is going to be bad." Sorry, but this is going to be bad. And the next morning was, I twisted his arm a bit, and he's the owner of the company is helping out on the production line, and we're going to do your project. Okay, that's going to save us 20 hours of work. No, it didn't. So this is where shit hits the fan. We made several significant boo-boos, which is why we got this nice little reversed logo. Thank you, Dimitri and the what do you call it? And Tim, Get Merch. Thank you for that. We made several. We made a bunch of mistakes. Some were done to us, others were done by us. For one, the little connector on the back is not supposed to be there. We specifically said, hey, we want it loose in the back, so you can solder it on yourself as an extra challenge, because it was supposed to go in the front. Which is, for you, it doesn't really matter, but if you want to use a shitty add-on, which a few friends of us were already planning to make, it doesn't work. Actually, you make reverse polarity, so stuff you put on there will probably burn. So, our good friends, and I forgot to add in the little slide which showed a nice little detail, made an extra board. So they made the beautiful scarab in a nice little kit. They assembled the kits here on in their bungalow. And the tiny little board you see there is the shitty add-on fixer. They have helped us fix shitty add-ons since last year with the helpful Other, and now they're fixing our shitty add-on again, making it slightly less shitty, and adding a beautiful scarab. So, and they gave them away for free. I don't know if there's any left. I'm looking at the people there. All out. Yeah, they made 30 of them and they gave them away for free. That's just pretty awesome. So, thanks for that. And thanks for the little add-on board. Are there any plans to do a second run of the scarab?
Yeah, maybe, why not?
Cool. Who would be interested in getting a scarab? Okay. That'll be 10 euros each, please.
So I guess the answer is yes then.
The answer is yes, people want it. It's beautiful. So, and it looks like this. It's absolutely gorgeous. So that's boo-boo number 1, and it's not so bad, because you could just plug in your USB serial on the back. Okay, you lost the soldering challenge, but whatever. Gonna be fine. Okay, next boo-boo. The lanyard. So we sent in this beautiful little design. And for those who are counting might notice this design is a bit longer than the one you have around your neck. So we got a pre-production photo. Hey, here's your render, and there were some folds in there. We were like, oh, this looks like it's okay, order it. And they chopped off the last 3 segments of the challenge. So the characters now spell out my name instead of the goddess we were supposed to get. What happens? But it's and we fixed it in software. Easy. It's luckily we checked. At least Sake took one home and said, "Oh, I'll check it." And oh crap! But 2 weeks ago, we received all the boxes of badges, and 100% of the badges were not working. Yeah. Oh, yeah. That's worse than we did at SHA, where we had 50% of them not working. And at SHA, it wasn't our fault, and this was, well, it was kind of our fault. We accepted fake parts, so this was definitely our fault. We did something wrong in reading the datasheet. We reversed all the LEDs and other diodes. Yeah. For those who are not really into electronics, if you reverse a diode, it doesn't work. Yeah, okay. It does work nicely as a barrier for electricity, and it does not make light. So, in total, 32 parts were reversed. So that's about 12,000 parts on these little boards that were on the wrong way round. Our fault. China was closed, and then an epidemic hit, so China was closed even more. So we couldn't fix it there. Say like, hey, here you have it back. Try again. No money to do it all over. No time. And this is the thing that's hilarious about us. We're not getting better at the process. We're getting better at thinking up fixes. So we came up with at least 4 different fixes. A friend of us came up with a new logo for us. We have the domain name. You don't have to try it. So the first fix, the minimum viable product, was, okay, we can just swap out the diodes in the power supply. You lose the LEDs, but at least the game can work. But it's meh. 21. Then there is, we could reverse all the LEDs and the diodes. That would take at least 30 minutes. It's the nicest, the purest edition, we like to call it. But it's very hard to do. At least for me, it's hard to do. Renzo says, "Oh no, it's easy. Just put it on a hot plate and then push it around with a little skewer." And yeah, 30 minutes, even with a trained eye, is too long. 30 minutes times 350 badges is impossible. We could replace all the MOSFETs, and we actually prepared for that. There's MOSFETs in the circuitry. I'll show you in a bit. We could swap that out. I even prepared stickers. Okay, pop quiz, little pop quiz. Kapton, at what temperature does it usually supposed to melt? Kapton tape. Melt? Exactly. So I ordered some Kapton sheets to isolate some pads so you could solder on top of it. And then I tried soldering on it, and it melted at less than 200 degrees, where it's supposed to go at 400 degrees. So that was out. Well. So, but it was kind of hard to do, and it was a lot of high-risk steps because you had to cut traces on the board and do other stuff, and it was not ideal. But it was doable, and it was less than half an hour. We think. We haven't actually tried it. So we came up with the final fix, which was removing the MOSFETs entirely, and then adding some wires in, which put the ATtiny out of spec. The ATtiny is specified to draw a certain to source a certain amount of current. We are way out of the specifications. It would lower our brightness. However, on the upside, it's easy to parallelize. Sorry. It's easiest to do. A bunch of the tasks can be done by untrained hand, and we did. So, step 1. We removed 5 times 350 MOSFETs with some pliers, because that's the fastest way to do it. And if you cut carefully, you only damage 1 board out of 350, so that's good. Yeah, I think there were 1 or 2 traces destroyed in this process, so it was excellent. Then there were some diodes in the power supply, which were removed with hot air, and then we put in either the same ones or some new ones. And then we added in some budge wires. We made a nice little map where you have to add in the wires. I'll show you in a bit. Thankfully, a few days before this sweatshop, the radio show Angry Nerds was on, and I was on a phone call with them, and I said, yeah, we're going to do a sweatshop, and it's going to be epic, but the problem is the lack of microscopes and proper soldering stations. We have the hands, but we don't have all the tools. So two of the hosts that were present kindly sponsored a bunch of money to be able to purchase a nice soldering station and this awesome little microscope, which is in the batch hacking area. So thank you, Brenno and Richard, for helping us out in our time of need. And it's slightly blurry, but it shows off the work that we did. You can see one just besides your battery clip on the left. So all those the little groups of free pads with a square around them, that's where MOSFET used to live. And we added in some little barge wires, 5 of them. So in about 10 hours, I think, we soldered in 5 times 350 barge wires. So that's 1750 wires. It's a lot of them. But they were working, all of them, except I think we broke 2 or 3 of them. So, that's why you have margins for error. Not because China is bad at producing them, but because we always mess up. Yeah, you have to be fair about that. The breakage from our production in China is usually between 1% and 2%. And we upped that to about 5%. So another sweatshop happened to make all the bags and to program and another night to program all the software in. It's a lot of stuff to do, especially if you have to fix them first. In the matter of eating your own dog food, we used SHA badges to program the code into your badges, because we still have a bunch of them. And it's easier to do this than set up a laptop and install some software and some dependencies, and then you have to do this Python scripts, which installs another 20 Python scripts, which install another 20 Python scripts, or you could just use a SHA badge. So what's coming soon for this for the SHA badge? We already have the EEPROM programmer in the hatchery, so you can just do that yourself if you want to. What's coming soon-ish? I'm looking at Jan. He's saying, it's going to be soon-ish. Soon you'll be able to, the code will be released today because we wanted to keep it a little bit secret from you. Soon there will be a compiler and a programmer software in the hatchery, so you can just write code for this badge in the hatchery, use a SHA badge to put it on, so you don't need to install toolchains on your laptop, that sort of stuff. We hope you will use these tools to make a master quest with this badge for next year. Just a little challenge for you people. Make a quest for us. That would be cool. So I'm going to switch it over to Sake, who is going to tell you about the quest. I'll be out of your way. And say the main effort? Yeah.
Okay. First of all, who solved all the challenges? Show your proud design. Throw your badges. Woo! Nice. Well done. Actually, the first 2 people, the first 3 people that solved it was on Friday night. They were working on it like for 12 hours straight, and big applause for these people because that's really, really amazing. For me, this whole frenzy started with a little tweet or a little Telegram message from Renzo, like, hey, we're going to do a simple microprocessor and we might want to do a game. Are you interested? Oh, okay, I'm interested. And then my life went down the drains. Because it started with a little processor, and we took a little bigger processor, and the ideas for the game were extended. And, well, I'm me, so I get carried away. And so I was thinking, I need a game that is, it needs to be simple, because it's only 16K of RAM. We need to address all the hardware, so there's not much room to really design a game. So I was really bugging my mind of how am I going to do this, and I ended up designing a JSON file format in which everything that you find in a game is just the same type of object, and it has some attributes. So what are the basic ones? You have, of course, a description. You have a name. That's what you see if you look at objects. There's an action mask on what you can do with this object. Can you talk to it? Can you use it? Can you look at it from the other objects? Stuff like that. Then there is ACL, so access control is. So when can you look at this object? When can you see it? Will it be visible or not? And that has messages like if you were trying to look at it and it doesn't, you're not allowed to. You get a message, and then I thought, oh, we need LED effects and sound effects. So I added the effects type as well. And basically, this is what controls the whole game. So this is one object. It's the room 101, in which you who turned on the television. Did you try to turn it off again? It really is room 101. One of the fun parts in this is that you can set a state, because the whole game is controlled by state. There's 127 state bits, of which in the end I only use like 20 or so. But based on these state bits, some things happen or don't happen. And you can actually set a state and use it in the same object again to toggle what you can do. So you can use the minibar once, but you can't use it twice. You get a different message. So that's all been done in this JSON format. And that's what that's my request to you. Like, I'm going to describe this JSON format for you. I'm going to give you the tools to compile this JSON format into the Flash format. And then if we put it somewhere that people can download it, flash it with their other badge, then you have a new game in the badge. So we're open sourcing the game format, and I hope somebody finds the time and the interest to develop new games for this. So when you compile the game, I had a 32K ROM to my proposal, or to my available. And people said, 32K, what are you doing? Are you writing a book? I said, no, I need to write a game. It needs some room. Okay. So I didn't know how much room I would need in the end. But in the end, it turned out to be 20K. That the whole game is 20K of data. So there's 61 objects in the game, and yeah, it's a lot of fun. I didn't expect people to be working on it this long, but that's because I always underestimate the time needed to solve my puzzles. I do other puzzles as well. So yeah, for me it was a real nice journey to be introduced to the badge team and do something useful for the badge team. I was on their Telegram list for a while, since Hackerhotel last year. And I wanted to be involved, but like I can't do a hardware design, I can't do firmware design, I can't do anything. Well, I can make a game. So this morning I found my cheat sheet. I have a T-shirt, a Wireshark keyboard shortcut cheat sheet. It's on the sticker table, and I found it on the table. I said, "Oh, really nice." People look at it, and then I noticed it was used as a just as a piece of paper to solve the puzzle from the badge. So that's where my two worlds collide, in this little piece of paper. Who was it that used this? Well, not it. Good, thank you. All right, that's my part. So I hope you enjoyed the game.
Het staat gewoon op mijn scherm. Gewoon pijltje naar rechts en dan.
Okay, now about the software. Let's see how this works. Yeah, okay. Yeah, I was invited to help out the badge team by, I don't know, I don't remember anymore, but I thought, yeah, I have a few spare hours. Yeah, I can help them out. Yeah, well, no, that was a mistake. And so, well, it turned out to be, I think, more than 200 hours, but oh well, it's done. And it worked, and people were enjoying it, so I'm glad I did it. About the microcontroller, I don't know if you can read any of it, but I'll tell you anyway. The ATtiny is a controller, one of the newer ones in the AVR series. And it has a nice set of features that some other AVR controllers don't have, like Arduino and other previous versions. Well, already mentioned, we had 16Ks of flash, some EEPROM, some SRAM, not much, but good enough. There's a 20 megahertz clock, which we divided in two to get the 10 megahertz we needed. Some ultra-low power clock that's used for timing, yeah, other things in the games. The program interface is a single-pin interface, so you can just program, debug, and yeah, do it with a single wire. And to make things easy for you, we added a little resistor, so you don't have to edit if you want to reprogram it with serial converter. You can just use a simple USB serial converter to program the batch. Well, that will be explained on the batch team website, I think. Yeah, okay. There's a lot of timers inside the chip. We used a lot of them. There is a single, or is it double? I know, there's one of the 16-bit timers that can be split in two. So you have 6 PWM channels for the LEDs to set the brightness, and they are synced together. So you can, yeah, just with a little piece of code, you can control all of the LEDs without user intervention. It's all interrupt-based, and we used about 10 interrupts for the whole batch to get everything running. Yeah, we had a serial UART inside of it, 2-wire interface. Yeah, that was a bit troublesome for me because I forgot that's a 7-bit address of the chip, and you have to shift it one left, and then you can get some data out of the chip. So last night, I think I wasted 5 hours just to find out that I had to shift the address of the chip to make it talk back to the ATtiny, and well, 5 hours left. But still, in the end, it worked, and I was really glad I could fix it in time, because we really needed some more lines of code because we were running out of flash space, about 10 times or so. Yeah. Yeah. In the end, we have 2 bytes left. That's 1 instruction word. Yeah. Yeah, it just fits. Yeah. Okay. Yeah. Another thing on this ATtiny is there's a digital to analog converter. It is only 8 bits, but it's enough for audio and stuff. You don't have to use timers to make a PWM wave and filter it and stuff like that to get an analog voltage. And it's easy to use, and we have used it for the audio and for the batch communications. So that was a really nice feature of this chip. The internal temperature sensor is also used in one of the challenges of the badges. Well, that's all cool. But the datasheet, previous datasheets made by Atmel were, well, they were fine, they were nice to read, structure was good. But Microchip bought AVR of Atmel, and they made this datasheet, but it's not really readable, at least for me. No addressing mentioned anywhere, I think. Lots of errors, and well, okay. I managed to get working code out of it, but well, it was a pain in the ass, but oh well, next time better. Okay, the examples were also unreadable, at least to me. They had this Atmel Studio thing, and they have some examples. And yeah, what I want you to write I2C interrupt routine. It should be just a few lines of code. But now they split it up in about 20 functions or something like that. In, I think, 10 libraries split. So it was unreadable to me, so, well, in the end, I wrote it myself. Yeah, yeah. And the software is also, yeah, it's only usable on Windows 10, the AVR Studio. And you can only install it when the temperature is right and the moon is, well, yeah, something like that. Yeah. Okay, now about code. We had, this is the main loop. Well, parts of it. Couldn't fit it on the screen, right? What it does is do some setup, some testing, game state loading, and after that there's a loop. And you see there, if generate audio, that's a thing that does the audio. The audio, if there's playing audio, it will consume the most time of the processor, because we needed to play samples, load it into memory, and make some noise and stuff like that. No, okay, audio is taking up the most part. Then we have the games. First, we have some LED blinking and victory dance. If you complete the badge, you get a nice blinky thing going on. Text adventure, magnet maze, lanyard code, best at dictates. It's all called from within the main loop. They only get a very small amount of time each, and then, well... Okay, I'll hurry up. Okay, so it all runs, and yeah, it doesn't take too much time to don't have much time to return to the main routine, so audio would else be very glitchy. Okay, a bit things about text venture. We had some cheat codes. I think nobody found out cheat codes, right? Did anyone find out cheat codes? Did anyone try to read out the external EPROM and decode it?
I tried both of those and nothing happened.
What?
What went wrong?
IDDQD, yeah. Oh, you tried? Really?
It didn't work.
Oh, okay. Maybe, yeah, oh well. Yeah, okay, should work. Maybe, yeah, has to be lowercase in this thing, I think. Yeah, sorry. Yeah. All right. Yep. Well, yeah, there's some hidden cheat codes. There are actual cheat codes. Oh, the hidden cheat code, if you find it, it resets the game state, so you have to start all over again. Oh, I'm sorry about that. Yeah. Yeah. And the priest talks in hexadecimal because we needed some more room for the code, so no divisions or modulo, except for the powers of 2. Yeah, only that. So hex it is. Okay. Some file for resources for doing stuff. Decryption. Well, it was decrypted, encrypted, but well, you should have been able to solve it. Generate audio. Well, you have to find out that yourself. You don't have time to do that, but it's just some. There's not really samples on there. It's all generated audio, real time. Yeah. Okay. Long times, no sleep. Well, for me at least sometimes, and for other people as well in the team. Yeah. Now debugging. I2C. I think I mentioned already. There's some errors in the datasheet. Optimizing code was taking a long time, but at least there were good people helping us and helping me, and yeah, it all went wrong. It went well in the end, and we had an awesome badge. So thank you. Yeah.
Okay. So I need to speed up, I think. Let's look a little bit at the event. There were a lot of people on a quest, which was fun. So the first day, technically the second day, the challenge was solved. But even today, I saw these people doing the little maze, hidden in plain sight. When I came into the hotel, I didn't even see it hanging, even though I made the damn thing. Well, I made the printout. The puzzle was, and the magnets and everything was Sakus. So. Without further ado, there were some winners to our little challenge. They stayed up until I think 5 a.m. I think they went 4:30 a.m. They were hacking that badge until I think they spent about 14 hours at least each. So Myrtle, Adot, and Tempestas, where are you? Okay, shall we have them up front, Dimitri? Shall we do that now? I'll give you this.
So yeah, here they are, the winners of this crazy contest. They worked through the night. We were drinking outside, lots of alcohol, and then suddenly someone stormed out. And at first it was Myrtle, followed by the other guys. And Myrtle was really the first one to came out of the restaurant, and I was like, yeah, I solved it. So that was really cool. And then deciding on the prize, before Hackerhotel, Renze said to me, this is a really hard challenge. If people would know how to solve this, they really deserve something. So basically I had one ticket for the one who solved it. Now it's free, so we leave it up to them how to divide it up to them, but they won one free ticket for a one-person room. So it's the equivalent worth of like this year's edition, 250 euros. So please give it up for the winners of this badge challenge.
And as a nice little commemoration, our friends had some little scarabs left over, so you can add those to your badge. So give them another round of applause, because I really need to speed up. Well done.
Congratulations, and see you next year.
Cool.
Maybe you guys, as you are so smart, can make us the new challenge.
Yes, I hope so. So, oh, by the way, there is one more badge. This weekend is Disobey in Finland. Renze somehow manages to help out with 2 badges in one go. He's holding one there. So Disobey, the Finland team, started out with our firmware, added on a lot of stuff. They have a push-to-talk walkie-talkie over Wi-Fi, I think. They run the same code base, they run the same hatchery. I think they made several thousand units. So the badge team firmware is now at least on 12,000 badges, as far as I can tell. Which is ridiculous. And now we're on the subject of numbers. Let's give you some more. We made 350 badges. We had 300 for the event. We reserved 10 for a specific sponsor whose condition to sponsor was, hey, I want to buy 10 badges in addition to our sponsor amount. So thank you for that. We had 40 badges for breakage and promo, so that's about 10%, which we usually do, 10 or 20%. We had 10,500 LEDs on there, which is insane considering it's 350 badges. We had 16 kilograms of AA batteries. We had 2 smoking capacitors. Very sorry about that. Somehow with mounting the battery boxes, we reversed a few and poof. And it's our tantalum capacitors, and tantalum is electrical engineers' terminology for highly flammable. Just so you know. There were, as far as we could tell, 0 cheaters or hacks. Lame. Come on. Where are all those chip whisperers, voltage glitching, whatever you do? Nobody decrypted the EEPROM. Come on. So I expect you to do your homework this weekend. Or next weekend. Come on, hack this thing. Let's see if you can figure it all out without you looking at the firmware. So, cost breakdown is up next. We spent about €11.30 per badge, roughly 4,000 euros in total, of which the PCB, just the bare board, was one of the more significant one, and the components. We had a huge discount on PCB assembly, about $500 worth of discount, so that saved a lot. Sorry?
Because of the design?
Yeah, because he liked us. We bought some USB serials, some bags. We had a sponsor this year for our drinks and pizza during the sweatshops, so thank you for that. It really helps out to keep volunteers hydrated and fed and happy, so they can do more work for us, so thank you for that. We spent 6% of the budget on customs. We spent 4% of the budget on batteries. Batteries are stupidly expensive. So we had some sponsors to make this all happen, so I'm going to name them all. And I'm probably mispronouncing all of them. So Magion, Stegen Electronics, Access 42. I can look here. Why am I looking there? Aureo ICT and Allnet China. Allnet China is also the producer, the person who arranged having this produced. So give them a round of applause, please. So before Dimitri kills me, I would like to do just a little sneak preview about what is next. And we're very sorry, we have no time for making a badge for Hackerhotel 21. But feel free to volunteer, make a little challenge for this, do a little design, whatever. We can support you, we can help you out, we can gives you some input, we can put you in touch with the right people. But it's up to someone else to make the Hackerhotel badge, because for us, it's MCH 2021, also known as Might Cause Hair Pulling. Yes, it may contain hackers. And we came up with a theme, which I think you'll like, because any sufficiently advanced technology is indistinguishable from magic. And magic is where we're going to go next with our badge. So we set some design goals already, and then I'm really going to close off. Design goals for Merlin's Cyber Heirloom is, on the technical side, we want to make FPGAs truly accessible. Not with this toolchain bullshit. Just... You cost me hours with your workshop, Paul. But the tool chains need to go if you want to play with these things at a camp. On the financial side, we have some goals. We want to make at least 4K units working, so we need to make 4.5 or 5K units. We have a budget of 75,000 euros. That comes down to, if you subtract the VAT and other stuff, roughly 12 euros and 40 cents per badge we can spend. So it's going to be another challenge to get it all done. It should be for the visitor, the user story, the thing that's actually most important to get people on your badge. This was one of the first we actually did a proper user story, and it worked out. It needs to be a name tag, again. It needs to be super easy to get started. People need to learn something. Should be enabled to learn something. You don't need to do anything. It's a holiday. We would like you to embark with others on a quest. More on that in the next months. And we really need to augment the event. So, timeline, what are we looking at? So this March till August, we're doing proof of concept stuff. Just experimenting with dev kits, tinkering stuff together, get our art and our theme proper, our user story correct, finding some component sponsors because FPGAs are not cheap. Out of this budget, we cannot do FPGAs. So we need to find some sponsors for that. And then in September, we should be able to do a prototype. In November, we should have the final design with the art. And then in January, we have final design, final 2 dot, whatever. And then in February, we can do a test run of final design, final, really final. And then March, we should be able to go into production, have the Gold Master firmware. And then in June and July, we should be able to do our sweatshops and do all the rework that needs to be done because we screwed up again. And then in August is MCH 2021, so please see us there. So, thanks to our badge team. Guru, Sake, Benatsky, Noor, Neko, Anjan, Tom and Renze. Thank you all for this. I didn't put it up.
No, and I completely agreed with this. It only says on it, as long as there's no dash in there, I don't care.
As long as there's no dash in there, it's all good. So, we have some honorary badge team members. Michael Stegen, who has been with us since the beginning, helping out at sweatshops while also sponsoring. Thank you for that. Rob Elboro, our sponsor for the sweatshops, helping out during sweatshops and sponsoring drinks and food. Yillis, where are you? Not here. He's doing his own workshop. Awesome person. Find him, do his workshop. He's great. And OP Raptor, also with us since Hackerhotel last year, I think. Thank you for all your shitty add-ons and help and everything. So, we would like, if you're interested in joining us on our quest to make nice quests for MCH21, we would like you to join us. We have a Telegram group. Sorry about that, but that's the easiest way to communicate for us right now. And you can join us and have a chat with us. And then if you're really enthusiastic, you can join the secret design group, which is never really a secret. We'll tweet about it anyway. But you can join us. We would like you to join us because the team is okay, but we would like some more people with varied skills. We don't need just electronic designers. We don't need just programmers. We have someone working on the storyline, someone working on quests, someone working on photography during our sweatshops. Everyone can help out, and it's fun to be part of this team. So that's it, as far as I can tell. So if you have any questions, please let me hear them. Oh, is there not one of those rubber things we can throw around at people, their faces? No? Oh. I haven't been to any talks, sorry.
There's no time. The next talk is already here. So.
The next talk is already here?
Yes.
Oh. Green lads. Find Benatsky later.
But. Hello.
Okay.
So, just before the other talk starts, I would like to have the badge team on stage, and I would like to ask our house photographer, maybe someone can wake him up in the corner over there. I would like to ask him to make a picture of the whole badge team in front of the Hackerhotel banner, because they did an awesome job. So give it up for them again, because they had sleepless nights. So we'll do a quick change over to Jos. Next talk will be about master keyed systems. So please don't leave yet. Jos will tell us all about his master keyed systems. Just a small few minutes and we're ready to go.
Ja. Hij is aan het denken. Oké, en nou moet ik... Hoi, hallo, echo, echo, echo. Dit is niet projecteur. Dat is projecteur. En dan moet
moet ik hier een ander skin pakken. Goed zo. En dat. Plus. Nee. Dat doet niks. Hij doet wel wat. Zie je dat? Ja. En dan hier naartoe.
Oh, staat op de andere.
Die gaat verkeerd. Slepen. Nog meer slepen. Oké, slideshow. Tussen wat? Ja. Goed. Leuk. Hier dingen doen. Oké. Nee, dat lukt wel. Moeilijk.
Ja, je zit er redelijk ver naast. Ja, daar mag ik.
Dus ik heb 3 kwartier. Is het bon? Ik ben nog klaar voor, denk ik.
Okay, ladies and gentlemen. We're now continuing with the talk of Jos Wijers, world champion impressioning. And it's about attacking master keyed systems. So please give it up for Jos Wijers.
Hello. I'm Jos Wijers. I'm a member of Tool. Tool is the open organization of lockpickers, and that means we open locks as a sport, as fun, mostly without force, with permission, and every now and then with keys. I'm going to talk about keys. Keys go in locks. This is a lock. Any questions? Okay, they go in lock. Duh. Do not touch that button. Try again. That's a lock, yes. Duh. If the round one, I should not do that. This is also black. Okay, so if the round thing turns, we call it open. And if you are actually talking about a door and an attacker, then it matters in what direction that round thing turns. As a sports picker, I don't care. If it turns, it turns. This talk is called Attacking Master Key Systems. And for that, I have to explain quite a lot of things. And so I'll start kindergarten level, this is this, and then we'll work up to the better parts. Okay, my slides will be, all the locks will be upside down, which is wrong, which is American, and that takes a bit of my filing times, so that's why I do this. If we look at this lock schematically, it's a round thing that we need to turn, and it has a hole in it. If you look into the hole, you see a piece of metal. Nothing much to see. So if you now take off one layer so you can look into the lock, so we're basically taking an MRI, then this happens. So you see, now you also see that why it doesn't turn, because there's a blue bit stuck in the way. What we need to do in order to open the lock is to use a special tool, it's called a key, and if we put that in, that whole pin stack gets lifted until there's a shear line, that's the line between blue and red, and if that's at the correct level, the lock can turn. right? Easy peasy. This is a one-pin lock. That should not really exist. So normally 5 is a normal number. So you have 5 pin stacks next to each other, and all those pins have to be at the correct level, lifted, so in order to open it. So that goes like this. So a key comes in, pushes all the things up. Now you can open this lock. And if this one is too deep at position number 2, because we start counting from the shoulder. And yeah, so number 2 is too deep now, so that won't open. And even if it's too high, it also won't open. So in theory, if we start turning a lock without a key in it, then there's 5 blue bits preventing it from turning, right? That's the theory. And of course, the real world doesn't really matter about theory, because in the real world we have crap like this. The thing with the holes in it, that's your cylinder, and the holes are the chambers where the pin stacks go in. That latch is supposed to be at a 90-degree angle, which it clearly isn't. This one has some wear and tear. If you look at these pins, they're supposed to be cylindrical. Well, they're cylindrical-ish. But yeah, so and even if they were made better than these, it's very hard to make 2 metal objects alike. You can make them look alike, but it's very hard to make them exactly identical to each other. If you zoom in enough, there will be a difference. And if you don't see a difference, you haven't zoomed in enough. So what that tells us, that if we look at the original picture again, with the 5 bits that are preventing this lock from turning, that's not really true. There's 1 bit that's preventing this lock from turning first. So if I start turning this lock, one of those blue bits will be the first one to get squished to the side, and that will prevent it from turning. Does that make sense? If we only look at that particular pin stack, so the one that gets stuck first, then we're back to this picture again. So what we can do, because if we do turn it, then it gets squished to the side. And if we then lift it up, there will be some, it'll feel like it doesn't want to go up because it's squished to the side. And then if we do lift it to the correct level, then your lock will turn ever so slightly until the next blue bit is preventing it from turning. And also, if you look at the blue bit now, it's stuck on that ledge. That would be ideally, so then we can take it step by step. Visually, looks like this. We have a lock. We put a turning force on there. Not too much, but enough for something to get stuck. We go in with a pick, and this is just gravity and a spring. Gravity and a spring. I'm not used to doing this at speed. This one doesn't want to go up, so that's the one we will push up. And with some luck, that stays there, and then we have to figure out what's now is the one that's stuck. It helps if you remember where you were, so you don't have to look at pins that you know that are set again. And this is basically what lockpicking is. But we have to understand lockpicking before we can explain impressioning, and then we have to explain master keying, and then we have to explain how to attack those. Yes, we have 45 minutes, won't be doing any questions. And then we have an open lock. So that's picking. Okay, but this is impressioning master key systems. So let's start about impressioning. With lockpicking, you can't half pick a lock because it's not open. And if you then have to leave because the guard comes in or whatever, and you start over again, then you really start over again. So if I'm attacking a door, how long would that take? Depends. And how long can I be in front of your, let's say, your server room door, without getting questioned, shot, dragged off, insulted? Is that 2 seconds? I guess I'm okay within 2 seconds, right? Can I be there for a minute, a whole minute, without being questioned? 10 maybe? 10 minutes? Well, if I am able to be at your server room door for 10 minutes without being questioned, I think we have other problems. But let's say those 2 seconds. I will not be questioned within 2 seconds, I think. Especially not if I'm holding a phone and wrong door and then shut off again. If I do that twice a day for about a week, will I get called upon? It's like, what did you do? I don't know. Well, that's a default state. So that okay. Remember this. We'll move along. What if we take that original lock that we saw before and put a key in it, but an uncut key, so a full key that has no cuts in it? Good thing we don't have microphones everywhere in the audience. Thank you for that. So with the picking, there were blue bits preventing the lock from turning. And now, because we have this hunk of metal in there, now it's all the red bits that are preventing the key from the lock from turning. But same principle applies. If I start turning this, there will be one of those bits will be the first one that prevents the cylinder from turning. Yes? Okay. So what we now can do is put a key in, start turning it, and we have now a very cool turning tool in there that's called a key. And so that's useful. And there's some give in your key. If you put your key in, you can wiggle it a bit. It's not a very snug fit, and it shouldn't be, because there's way too much wear and tear. So there is some give. And that means that what you can do, if you start turning this, and put your key, move your key up and down a bit, then on position 1, 2, 3, and 5, you'll just be pushing those pins up. Because the only thing that's holding them back is a spring and a tiny bit of gravity. But in position 4, the pin doesn't want to go up, because that's the one stuck to the side. So if you look at where that pin is touching your key, on position number 4, there will be a bigger force on your key than on the other 4 positions. Yes? Okay. So what we're going to do, key in, turn, wiggle, wiggle, wiggle. Then turn the other side, which now we can do because there's metal in the way, and do that also there. And with some luck, another pin will preventing it from turning in that direction. If we then take the key out and look at it very carefully, then you see, and it's not that obvious, which is correct, it's quite hard to see, that's why we have magnification aids, and there's a mark there and there's a mark there. Because keys are quite soft material, and if you look at your key closely, then you will see where the bigger forces occurred. So what we do, that looks a bit like this, and so what we're going to do at the positions where these marks are, we're going to take off some material. And some is the scientific term here. There are charts, if you know what brand it is, how much to take away. And if you don't have those charts, then it should be not too much. It's baby steps. Okay, then that's still not a working key. If we put this same key in again, and we start over, rinse and repeat. If we start turning this pin is probably still the one preventing it from turning in that direction. So that will make a mark. This pin, same thing, will make a mark. So there's marks in the valleys we just created, there, and it looks a bit like this. And what we're going to do is, at those marks, we take away more material. So rinse and repeat. So what comes next? Well, actually, this pin is done. That's on the correct level. So if we start turning in one direction, then with some luck, another pin will be the one preventing it from turning in that direction first. So if we start wiggling this, there will still be a mark there, because nothing changed at that position. This position won't mark, because, well, it wasn't stuck there. But on another position, there will be a pin that's preventing it from turning in that direction. So we file off even more material. We keep on doing this until we have a working key. That will look vaguely a bit like this. On top, there's the original key that I didn't have, and at the bottom is the one I created. It looks a bit weird. It looks like a shark took a bite out of it, but that's because I use a round file instead of a squarey one, which is way easier. And now we're going to demo this. If you're any good, you win prizes. And demo. Demo all the things. There is a quite high possibility of fail. See, don't need this. Nope. We have all sorts of stuff. This is a lock. Actually, it's 2 locks, but let's start at number 1. We have a key that I've prepared. It's the surface is a bit smoother now, so I should be able to see marks. Key in. I use a handle to have a bit more force on it, but basically still a key. Turning force one direction, move it up and down, make it a bit less jiggly. So I move it one direction, other direction while I'm jiggling. And then I look at the key. Marks can be quite subtle. And I take off some material. Like you saw, that's some. We
How many pins do we have?
Of course, that was theory. And so it's not all that linear. So a pin might stop marking at some point, but doesn't necessarily mean it's at the correct level yet. But if everything stops marking, then you're... Yeah, that's a technical term, yeah. And of course, if you overfile, so file too much at some point, then it's indeed, then you're fucked. And to be honest, I thought we reached that now-ish. Okay, rinse and repeat. I overfiled.
Where do you get those blanks?
If you're nice to your local locksmith, then it gets there. eBay is your friend also. Sorry?
But you can get iron instead of bronze.
Yeah. Fransbach said if you buy keys of the interwebs, you might get iron keys, steel keys instead of bronze. That's true.
Yeah.
And yeah, then you order more and hope for the best.
Iron is steel is too hard.
Yeah, a steel key won't mark that easily because, well, it doesn't dent that good, and filing is harder. Open. And that's just step one. Oh, was anyone faster? I do have pointy metal bits here. Okay, now it's smooth, so that works. Okay, so that works on a normal pin stack. This is a opened lock, opened differently than you're used to. What you see in the middle, because you have those pins at the bottom. I'm not going to use this as a pointy device because then stuff goes back. Those halter-shaped pins, those are halter pins. Those are meant to prevent you from picking your lock because it makes it harder or more interesting, depends how you look at it. But because I start off with a full key, the moment these come in play, I'm too far already. So it doesn't do anything to deter this piece of picking. Also, nasty pins, nasty key pins can make it a bit harder. We'll do that later. But yeah, makes it more interesting. And also dimple locks, this technique works very well on dimple locks, because you don't have to file that deep. So the key you see is filed across. And if you take a blank at the bottom and I cut the key above with a 1, 2, 3, 4, 5, 6 depth. So you go deeper and deeper and deeper. So in the end, you file actually through the key, but well, care. Okay, but the talk is called Impressioning Master Key Systems. What the heck is a master key system? This is a master key system. So we just look at the key pins, so the pins that are touching your key. And the ones, the housing pins, the ones above that, those are not interesting at the moment. And what we see is that in position 2, 3, and 3, 4, and 5, there's an extra pin in there. It's a disk, and that means that you can do all sorts of cool stuff, because now you have 2 positions. You have more keys that work in this lock. Why they do this is if you have a bigger building, so you have a lot of doors, every door has a key, but there's a boss key or a cleaner's key, whatever. So there's one key that can open multiple doors. And maybe there's more of those, and there's one Uber master key that opens all the doors. As an attacker, of course, you want the top one, because that's root. That's if you have that key, that will open all the doors. Okay, so if you look at this pin stack, then, well, if you look at the first 2 pins, that's easy. Those have to be lifted to the correct level, and then it's open, right? But if you look at this pin, this will open, so will this. So we have 2 possible keys for these 3 pins. And that adds up if you put more disks in there. And of course now, on only 3 positions, there's a disk. And so this will open, but also this will open. That will open. That will open. So that adds up. And if you put more disks in a single pin stack, that adds it even up more. So you end up with quite a lot of possibilities. But I want to have that top one, because all those possibilities open that door. And one of these is your master. So you're on a red team, you take your box with you, and then you try your key and try your key and try your key. Oh, this one opens. Might it be the master? You go to the next door. No, it's not. Rinse and repeat. So we have to figure out a way to get to the top. This Matt Blaze, he wrote a white paper on it. What they basically did, what used to be the normal way, is you have a lock and a working key, a valid working key, not the one you just filed, but a valid working key. That operates the door, right? Then you copy that key apart from one position. So you do not duplicate position 1 and 2, 3, 4, and 5. You do. That will not open your lock. Take one position off, take one position off until it opens, and then keep on going. So you get a complete map how this looks like. But still, then you have a map of what the internals looks like. But you still have, again, a shitload of options. So it's hard. So yeah, if they're all key pins, if they're all have disk in it, then it's 30 something, but that adds up quite a lot if you put more disk in it. So what we're going to do, about 10 years ago, I had a thought experiment and I came up with a solution, I thought. And then I talked to a couple of guys and they said, well, it's that easy, it can't be true. That's what they said about the paper clips. So it is quite easy. And that was 10 years ago, so I decided to get it into the open. First, we'll start off with some animation stuff. This is made by... Okay, we have 3 locks. Because reasons. Boom. I had this idea to do this visually, and then I explained it to Jan Willem, which designed these pins. First he made a wooden thing that I really liked, and then all of a sudden there was an update, an upgrade, and we have this. The 3 locks and some spare parts. We have a blank key. This is a key, so if you put it in there, this will lift up all the keys, all the pins, right? This is your shear line. So the key should be something like this, right? And then rinse and repeat. But if I start off with a blank key, well, if I do that, so if I impression this, this will mark, that will mark, that will mark, that will mark. They all mark at the first time. So I speed up a bit, because of course that would be 1 or 2 pins at the same time. Boom. Boom. No, that's within the lines. No, still not there. So, impression a bit more. It's quite faster this way than actually filing. And of course, having see-through locks is also very helpful. So don't actually use those padlocks you get from China, right? This one would mark, that one would mark. So 1, 2, 3, 1. That. Okay. 1, 5. Sorry? I. That one's almost there. That one's not. So, ta-ta-ta-ta-ta. Okay. Is that open? Put er nog eentje. Hoe is het? Whatever. Yeah, let's call this an open. With a see-through lock. Actually, I don't think this. I think this is. That one's still marking, I presume. Yeah, that's better. Now it's smooth. Okay, so this is a key to this lock, because this is also a key. This is a key, but this is the first one we reach. So this is exactly what I've done there. I just start off with the blank key until it opens. I call it a key that's working on that door. And I don't know the status yet, because there's a possibility that that is also, well, this is one of the lot of keys in that box that works. So you go to a second door with that same key you just got and figure out if that still works. Well, that one's good. Almost. Okay, so nope, that's not opening. So if I start impressioning it, same key on that lock, then it'll mark there. Still marked there. That will open. So now we have. Second step is easier, because I'm doing less. There are a lot of these pins I haven't even touched yet on the key. So now we have a working key for this lock. Go back to door number 1 with this lock, with this key. That's not going to work. Okay, well, I'm at this door anyhow, so keep on filing. Nope. Now that opens again. Will that be the master key? Door number 2. Uh-huh. See, those are round times. So then I go to another door. Let's see if this is straight. That'll work. That'll work. That'll work. That should work. See? Kinda, yeah. It won't go smooth, but it'll open. And of course, there's a magical 4th door that will open also. So we now have a master key. And from all the possible combinations, I used one blank instead of a box. Okay, that was theory. Yeah, let's do scary shit. Demo. We have made, well, not we, Holly Poor, a very competent locksmith from America, hit me up with a master key system consisting of 20 doors, of which I have 4 of the locks. Internals look like this. Yes, that's considered cheating, but let's. And yeah, let's see how it goes. Door number 1 is open, because that's the one I impressioned before. That looks like this. That's the internals of it. The key should look vaguely a bit like that. Yeah. And like I said, we have a master key system. So we have multiple doors. It's door number 1, door number 2, door number 3 and 4. So door number 1 opened. We proved that. Door number 2, negative. This is 3. Negative. 4 is a yes. Okay, so we have one key that opens 1 and 4. 2 and 3 not. Okay. So this key does not work on lock number 2. Lock number 2. And at this point, it would be actually wise to copy this key. Because reasons. Yeah, then you're fucked anyhow, yeah. This is the same core as, the question was, what is the little tool you put over your key every now and then? That's a sort of core, so it's the inner workings of the lock, without any pins or springs or anything in it. If you look through the holes where normally the springs and the pins would be, then you see the exact position where the pins would have been. So that means you also have a clear view of the piece of key where the pins would touch. So if you're hunting for marks, this basically tells you exactly where the marks should be. And they aren't, of course. We have an open lock. Yeah, because It's way shorter than the initial lock, because, well, a lot of the work was done already. Hoeveel dingen neergelegd? Daar, oké. Out. That should look a bit like that. Yeah, ish. Okay. So we made a key for door number 2. And let's see how door number 1 does now. That's a negative. 2 works, we know that. This is 3. 3 works, okay. So at least we have some subby master or something like that. 4 is a negative. So, negative, positive, positive, negative. Okay, so it doesn't work on door number 1. Let's go to door number 1. Door number 1. Let's make that a bit clearer. Yeah. Open. Okay. So that's door number 1 again. And that should look a bit... well, it does open number 1. It does open number 2. Let's ignore that one. Oh, it's apparently not. Okay. That still works. Oh. That still works. Go up. That still works. That still works. That works. So you keep on moving from door to door until stuff happens. And yeah. Why won't you open? It's magic. So we have one key that opens everything, right? Okay, but you got the general idea. So you impression a lock, And you basically keep on doing that to your key. So you keep abusing the same key over and over and over again until it works there, it doesn't work here. Okay, I'll start preparing it for there. So instead of that whole box of keys, you have one. And as you saw, it helps a bit to practice. Any questions? Well, lock 1 and 2 got quite some abuse. But the abuse is on the pins, because you torque the lock quite hard, harder than you would normally do with your hand, with just your bare hands. But you really need to gut your lock quite completely, saw it open, and look at it that way. Then you will find forensic traces on lock number 1 and 2. Lock number 4 I barely touched. So lock number 4 will have the same forensics as you using a wrong key in that door, which is quite close to 0. So forensically on lock number 4, good luck to you. Forensically on lock number 1, you won't be opening your lock that way. You won't do a forensic research unless you really know somebody got in. So from the outside, your lock still works. It has no more wear and tear than normal-ish. You really have to gut your lock completely to figure out what happened. And once you do that, the signs are quite clear if you know where to look. But on 4, you shit out a lock. On 1, you'll see that. So what you could do in an attack scenario, because 1 took the most abuse, is steal that lock. This could be a key to like padlock or something like that. Or a fence or anything with tiny legs. I don't know. Any more questions? Yes?
Are there defenses against it, or is it
Guns help every now and then. Because I am doing weird shit at your door. The question was, is there any defense against this? Not that much. No. I do need to be able to get these blanks. Some blanks are harder to get, but we're still talking about a piece of metal in a certain shape. There are ways, shape ways, whatever. You can buy blanks, but it's quite hard to defend against that. I had one picture with the funky, with the weird key pins. That makes it harder. It makes it definitely more interesting. And because all these were just flush, normal, regular pins, and I still be able to fail. So it's harder on more intricate locks, but we're talking harder. Definitely not impossible. Any more questions? There's a question there.
if the master key is always at the lowest, basically finding down the key the most?
Nope. That would be very bad. The question was, is a master key always the one you can file down? Is that the way correct?
Can you always file down to the master key like you're doing right now?
No. I can do this because I start with a uncut key. If I start cutting, yeah.
Sure, but what I mean is, basically you start with the first lock, it opens.
Uh-huh.
The second lock, it opens. Is the result of your procedure always going to be a master key, so do you always only need to take away material?
Yes. If I only look at this pin stack, right? So blank key will push it all up because there's a lot of metal. And I start filing until I reach a shear line. This shear line could be, it's a shear line. Is it the master shear line or not? Those are your two options.
So what I mean is...
No. The two options are this shear line is your master shear line or not, right? If that's your master shear line, it will be on all locks, because otherwise it's not the master. So that one will never mark again. So if it does mark somewhere, then this wasn't the master shear line. So then I need to file further until I do reach the master shear line. So once I reach it, it's done, it won't mark again.
So actually my question is different. This was just an answer to my question.
Sorry?
If your master key always has the deepest holes of all the keys.
It doesn't.
It doesn't, okay.
No. It's the first common match that I'm looking for. Because if this is the master, it will never mark. But yes, there's a key that opens it on that one, which is not the master. Dan laten we die bij, want de tijd is op.
Okay. Thank you very much, Jos, for being here again. And there were some guys from Red Team Security that had a quick announcement to make. So while we change over to the last talk before my closing talk, I'd like to ask these guys from Red Team Security forward, or guy or guys. And also we can start doing the switch over. I'll give the microphone to Sander.
Hi guys, we did yesterday evening whiskey tasting, so we brought a few whiskeys with us. And last week we talked also with Timon from Hack 42, and he had a brilliant idea of one of the 9 whiskies we took with us, then to make a sort of infinity bottle of the most favorite whiskies all people choose yesterday evening. And this morning we made that infinity bottle for you. We want to hand it over, and maybe it's an idea for the next episode of Hackerhotel to let it come back, and so we can share it again.
So it's a mix, basically.
It's a mix.
Blend.
It's a blend of all the single malts which were chosen yesterday as the favorites.
Which one was the favorite?
Well, the most favorite was what was it? The Talisker. It was chosen by the most favorite, and which one was it again? Which was
That one was empty.
Yeah, that one was empty. But
I remember that, sort of.
Yeah, of course. So that's the bottle we choose for the blends, and hopefully we will see him next year back again on Hackerhotel.
And a big thanks for the guys from Red Team Security, and not only for bringing all these lovely whiskies, the special limited edition of the Game of Thrones series, but also thanks to the other guys that contributed into the music stuff, but also the smoked salmon infused with whiskey. Give it up. And also all the other whiskies that the other people brought. So if you like it, we might repeat it next year. So let's do a quick vote. Just clap if you liked it, and if you really liked it, clap hard. So I hope I see you back next year. It was an awesome experience, and for the guys that missed it and the other people that missed it, then it was really awesome. And there's one question.
Next year, please, not in parallel with the pub quiz.
Okay, yeah, we thought we just started ahead to have a quick taste. But everybody was welcome. So I'll keep that in mind. Thanks, good feedback. So we'll do a switch over now to the last talk before my closing talk. So I would like to ask the next speaker up. I don't know. So we're waiting for the next speaker. I hope he's not in the hardware workshop.